Okay, the last thing we're going to look at today is looking at deceptive graphs so that you can be a bit more informed consumer when you're looking at graphs out in the real world, and also know some points about how to make correct graphs. So the first example we've got here is this particular graph that doesn't have a vertical axis. Now, this type of graph is really more of a marketing type of stuff. It's not actually very informative. So without any type of vertical axis, there's no way for me to be able to make any kind of assessment of actual amounts. So it's a nice visual, it's snazzy, it's selling, but it's not informative. The next is looking at images. Now this data comes from the website Project 538, done by Nate Silver in looking at predictions for the last presidential election. Now, although the presidential election of Donald Trump took everybody by surprise, Nate Silver was actually the only person in his polls that was giving him a 32% chance of winning. So Nate Silver, although still off, had a better estimate of Trump's likelihood of winning the presidential election. So let's take a look at the representations of the data he's got from his site. Now, he represents the data for the electoral colleges in two different formats. The one here on the left is the electoral colleges as they're plugged into the actual shape of the United States, with each state colored. Okay? Now, looking at the right is a different version of the same information. However, it is done by the electoral college votes. So, each state is then identified with a small hexagram that for each electoral college vote it controls. So, when we're looking at these two different graphs, take a few moments and look at them and notice what are some of the differences you can see in how information is represented between these two different graphs. One of the big ones, for example, is the impact of California. Although California is a large state, it's also very densely populated. So its representation, when we're using simply the shape of the state, actually kind of underemphasizes the amount of impact California has on the nation as a whole. Another important difference is Montana. So due to land size, Montana looks quite large in the United States map. But when we're looking at its electoral college votes, it actually only carries the minimum amount of 3. So it doesn't have nearly as much of an impact as it looks like in the graphic representation based on state size. New Jersey's another place. If you're looking at the size of the state, it's really quite small. However, you can see it does pull quite a heavy electoral college votes despite its size. So, when looking at these, we wanted to have an understanding quickly of how the electoral votes were falling out across the election time period. The graph on the right, although not as visually accurate in terms of landmass, is more visually accurate in terms of electoral college vote impact. In general, anything that's done on the shape of a particular image, like the United States, by its state sizes, or looking at, for example, something shaped by a dollar, any of these other really snazzy looking images that people like to use, again, that's more marketing, but it's not informative. Here's another really important problem when we look at these two different graphs. Now, these are the same data, and they're done on different y-axes. So, we're looking at the one on the left, it looks like there's a really huge difference between 2008 and 2012. Really important in interest rates, right? However, looking at the same data now, but done with a 0 point on the y-axis, that difference doesn't look very meaningful at all. It's a very small difference. So this uses the idea that human beings are visual processors of information. So we're visual learners, and we process information visually long before we had language and numbers. So this is an example of where I can represent data in two different ways depending upon what kind of effect I want to elicit from you. People looking at the image on the left are going to be likely to think that there is a really large difference, even if they take the time to count through the numbers. So the visual representation can often dominate over the numerical or language information. When we're looking at this particular one, what we see is that the graph on the left is actually a blow-up of a very small part of the graph on the right. So it misrepresents the impact over years of interest rates and how they've gone up, leading to one particular impression. However, do notice they're not lying. This is not a lie. It is simply a choice of how to represent the information. So whenever somebody is giving you information in any type of bar graph or anything like this, always insist a 0 point on your y-axis before you look at the information, and you should always be including that in any of the work you do in this class. Another important thing to think about is cutoff points in data presented. So if we're looking at this particular image here, which is coming from the Congressional Budget Office in 2012, it looks as if the deficit has been a large ongoing problem for quite a while. However, we need to pay attention to A, when this data was cut off at, and notice also it's making projections forward. We are not in 2019 yet, and this was done in 2012. So they've done two things here. First of all, they've cut it off at 2009, and we want to know why they're cutting off at 2009, not at a different time, and they're also projecting way past what their data actually is. So, and they're covering that area where they're projecting forward exactly the same. So it looks like it's all part of the same thing. They're not indicating that some of this is actual measured and some of it is projected. Now, what is important to know about this is in 2007, when we were looking at this, the only just 1.2% of the gross national product was the deficit when the housing market collapsed. So whenever somebody is giving you data cut off at a certain point like this, the first thing you want to do is you want to ask for the full data set. I want a full representation of all of that data, because you want to ask yourself, why are they choosing to cut it off in certain points? Why did they choose to cut off in 2009 instead of 2007? There might be a good reason, but you should always ask that question, at least of yourself. Also, again, you should always ask for the larger piece of data so that you can embed the smaller section in that larger piece. That gives you a more accurate image, again, of how things are unfolding across time. Lastly, if we're looking at something for projections, again, really that should be colored in a different manner because those are not actual measurements. A projection is not the same thing as an actual measurement. The other thing when we're looking at cutoff points is when people cut off data and stop before where we are right now. So again, looking at some information, if I was looking at information regarding unemployment and it stopped at 2012 and somebody was presenting as like, this is the state of our unemployment right now, I would not be comfortable with that information. We're in 2017, we're new into it, but at least certainly you should be able to give me information from 2016. So why are you choosing to give your report from say 2009 to 2012? Why are you not carrying this forward in the most recent data? So these are all really important questions to ask when you're looking at representations of data. This will help you understand more accurately what is going on, which is essential, again, for making good, informed decisions. All right, now, the last thing we're going to look at here is data points that are plotted incorrectly. So looking at this particular data production, we're looking at unemployment rate. Notice on the left-hand side, the space between 9% and 8.9% drops off quite a bit. However, for all the way over on the right-hand side, the space between 9 and 8.6% is in fact even. Once again, pay attention that human beings process data visually. So most people looking at this, especially very quickly when you're watching a TV show, are going to be more impressed by the shape of the distribution than by the actual numbers. However, they would be able to say that their numbers were accurate. Do you follow me on this distinction? Their numbers are accurate. How they graph them, however, is not. And that's a source of a problem. Lastly, also notice they have no 0 point here. So we've already talked about how that is a problem. So hopefully with this section looking at graphing of data and how to think critically about it will help you be a little bit more consumed, a little bit more of a critical consumer of data yourself as you go about your life. So as you're going through this semester, pay attention to representations of data and start asking yourself questions about what's being included and what's being left off, and pay a little bit more attention about how things are being represented and notice how they can give different impressions while still using technically the same numbers.